Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in. Okay, so first half-life question on the left here, we have a source with an activity of 40 becquerels, and that falls to 5 becquerels in 5 seconds. What is the half-life of the source? Okay, first things first, I'm just going to write out all the information that I have in shorthand. So I go from an initial activity of 40 to 5 in 5 seconds. Okay, good. So I've got all the information there. Now, as with most of our half-life questions, the first thing I need to do is to figure out how many half-lives have passed during that 5 seconds. And in order to do that, what I need to do is to take my initial activity, so in this case it's going to be 40, and keep dividing that number by 2, 2, 2, 2, 2, so on and so forth, until I reach my final activity, which is 5 becquerels. So let me do it here with 40. If I first divide 40 by 2, I get 20. Then if I divide 20 by 2, I get 10. And then if I divide 10 by 2, I get 5. So you follow this process of halving down until you reach your final activity. Okay, and then I need to count how many times did I need to divide by 2 to reach my final activity. So in this case, I did that 3 times. So that tells me how many half-lives have passed. There were 3 half-lives, and that took a total of 5 seconds. So if I want to figure out how long one half-life is, and 3 of them took 5 seconds, well, if I just divide that 5 by 3, then I figure out that one half-life is 1.67 seconds. Okay, next question. A source's activity falls to 50% of its original value in 10 seconds. What is the half-life? So again, let me just write this out. I'm going from 100% to 50% in 10 seconds. Okay, so again, exactly the same idea. I need to figure out how many half-lives have passed. And I haven't been given an initial and a final activity here. I've been given percentages. So the original activity of this is 100%, and that drops to 50% of its original value. So if I'm trying to figure out how many half-lives have passed, that is 100 divided by 2 already gives me 50. So actually only one half-life has passed. So you can do the percentages in exactly the same way, just dividing by 2 until you reach your final percentage. So one half-life passed in 10 seconds, so 10 seconds must be equal to one half-life. Okay, next question. On the left here, we have what is a final activity of a source with an original activity of 60 becquerels and a half-life of 6 hours after 18 hours. Okay, so let me write my stuff out. So I'm going from 60 to some unknown final activity in 18 hours. Okay, I'm going to ask myself the same question. How many half-lives have passed? But this time I've been given some slightly different information. Rather than having been given an initial and final activity, I have been given a half-life and a total time. So it tells me that 18 hours is the total time for this decay, and each half-life is 6 hours. So 18 divided by 6 tells me that there have been 3 6-hour periods in this 18 hours. So 3 half-lives in total will have passed during that 18 hours. Okay, then comes the part where I start dividing by 2 to find my final activity. So 3 half-lives tells me that 60 gets divided by 2 3 times. So if I do it once, I get 30. If I do it again, I get 15. And the final half-life passing, I get 7.5 becquerels as my final activity. Okay. Next question, what is the original activity of a source with a final activity of 10 becquerels and a half-life of 2 hours after 10 hours? Okay, so this time I'm going to write this out. I've actually been given my final activity was 10 becquerels and I'm looking for my initial activity and I've been told that 10 hours has passed. So again, I need to ask myself how many half-lives have passed in this time, and it was a total time of 10 hours. Each half-life was 2 hours, so 10 divided by 2 tells me that 5 half-lives have passed. Okay, now this one's a bit different because I'm looking for the original activity, which I divided by 2 5 times to reach 10. So I need to work in the opposite direction now and take that final activity 10 and keep multiplying it by 2 5 times to reach my initial activity. So this example is slightly more complicated, and more often than not in your GCSE you will be given your initial and be trying to work out your final. But it's useful nonetheless to do an example this way round. So let's continue. My final was 10, so if I times it by 2 once, that gives me 20. By 2 again, that gives me 40. By 2 again, 80. 2 again, 160. And times 2 again, 320. So that's me multiplying by 2 5 times in total to give me that initial activity of 320 becquerels. You could maybe prove to yourself that this is true by now taking 320 and dividing by 2 5 times to find that your final activity would be 10 becquerels. Okay, and my question on the left, what is the time if a source has an activity of 100 becquerels at 10 AM and has a half-life of 5 minutes? And the activity is now 12.5 becquerels. Okay, let's break this down. So we have a source which is going from 100 becquerels to 12.5 becquerels. And we're basically trying to figure out how long it took for the source to do that. So again, my first question is, well, how many half-lives have had to pass to get from 100 to 12.5 becquerels? So let's do that bit first. So we divide 100 by 2 once to get 50, again to get 25, and again to get 12.5. So that is 3 divisions by 2, so 3 half-lives that have passed. And it tells me in the question that each half-life is worth 5 minutes. So 3 have passed, multiplied by 5 gives me a total of 15 minutes for this to have happened. The actual question asks me what the time is now, considering that the activity was 100 becquerels at 10 AM. So 15 minutes must have elapsed between the start of this activity at 10 AM. So it must be 10:15 AM now. Okay, next question. How long does it take a source with a half-life of 2 seconds to go from 120,000 CPM? CPM is just another unit of activity. It stands for counts per minute, so how many decays happen every minute, to 6.25% of this value. Okay, let me write the information out. So we're going from 120,000 to 6.25% of 120,000. And of course, as always, I'm going to ask myself, well, how many half-lives have passed to get from 120,000 to 6.25% of 120,000? Well, first I need to work out what is 6.25% of 120,000. And to do that, you multiply 120,000 by 6.25 and divide that number by 100. So that in the end is the same as multiplying by 0.0625, and it gives you 7,500 becquerels. Okay, so that's my final activity. Now to work out how many half-lives have passed to get there. So after one half-life, I'm at 60,000, and after two half-lives, I'm at 30,000. After three half-lives, I'm at 15,000, and after four, I'm at 7,500. So that is a total of 4 half-lives that have passed, and each half-life from my information in my question takes 2 seconds. So 4 multiplied by 2 gives me 8 seconds in total. Now, just a note on this question, I didn't actually have to work out 6.25% of 120,000. I could have, like in our previous examples, just stated that the initial activity was 100% and the final was 6.25%, and could have kept dividing 100 by 2. So once to 50, twice to 25, 3 times to 12.5, and 4 times for the 6.25. And I would have found 4 half-lives doing it that way as well. And that way probably would have been a little bit quicker. Okay, but for completeness, I wanted to figure out what 6.25% of 120,000 was and follow it through this way. Okay, now to look at some half-life graphs. So you either have activity on your y-axis and time on your x-axis, or sometimes you will have the number of undecayed nuclei on your y-axis. So either of those things, these graphs work in the exact same way. So first, finding a half-life of a source from a graph. So you can take any point on your graph. For ease, I'm going to take that green point highlighted there. So the first point on my graph, so 4,000 becquerels activity at time equal to 0. And basically, you find the point on your y-axis, which is half of whatever that initial activity is. So 4,000 divided by 2 is 2,000. And then you find the x value of that point on your graph. So I find if I trace that down, that happens at time 2 hours. And that is the time of my half-life. Just to be clear, my half-life is 2 hours because the time elapsed between when it was 4,000 and 2,000 was between 0 time and 2 hours. You can do this at any point of your graph, which means if I took my initial point to be this 2,000 at 2 hours, my final point would be 1,000, which, as you can see, if I highlight it here, actually then happens at a time equivalent to 4 hours. But still, the difference between my initial and final time is 2 hours. So that is the half-life of my source. Okay, how long does it take my source to drop by 40%? So, in order to figure out how long it's going to take to drop by 40%, I need to first figure out what on earth that means. So when I'm doing this, if it's dropping by 40%, that means that it will be 60% of its original activity. So what the question's really asking me to figure out is, what is 60% of that initial activity, 4,000? So to do that, we multiply 4,000 by 60 and divide by 100, which is the equivalent to multiplying by 0.6. And we find that the final activity is 2,400. Then I need to find what time that is on my graph. So if I draw a line at roughly 2,400 there, then I find that my time is roughly at 1.5 hours. That's not very accurate. This isn't a very good scaled graph, but in your exam, you should have smaller divisions so you can see exactly how much time has elapsed. Okay, and the final question is to draw a graph of the half-life of this original graph. So what that's asking me to do is to draw the graph of a substance that, instead of having a half-life of 2 hours, actually has a half-life of 1 hour. So let me show you what that graph looks like now. It should look something like this, and I've calculated that doing the following. So the first point that I've plotted is there, where my initial activity is the same. And then the next point along, well, I need to halve my activity, so that gets me to 2,000 becquerels, and that needed to happen in 1 hour. So that's why that point's there. When that activity halves again to 1,000 becquerels, that takes another hour, and then half again to 500, that takes another hour, and then so on and so forth. So you can sketch this graph for a substance with a half-life of 1 hour. Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not? Okay, so my little tips and tricks for this section, talking about activity units. So you could get given becquerels. We saw some counts per minute. That's an activity unit as well. Or something like mega becquerels, something with a prefix in front of it. And your times, you could have hours, days, years, seconds, whatever. So the thing is, when you are working out half-lives, you actually keep your time units as they are. There's no need to convert times from hours, days or years into seconds. You keep it as it is, and your activity you keep in the units that they give you as well. If they give you counts per minute, keep it in counts per minute. Don't try and figure out how many decays that is per second. It's fine. So this is one of the rare points in your course where you're not worried about converting time into seconds. Okay. Find how many half-lives have passed. Yes, this is just, if you look at a half-life question and you're not sure where to start, that is your initial thought. How many half-lives have passed? You might need to do that by using the initial and final activity and seeing how many times you need to divide by 2, or you might be given a half-life and given an amount of time and therefore have to figure out, well, how many half-lives could have elapsed during that time. But either way, that can be your first thought and you can go from there. Finally, if they ever ask you to sketch a half-life graph, just make sure that your graph never hits 0 at the bottom. So don't draw the line and hit 0 on your y-axis. Don't cross your x-axis ever. Okay, make sure that it just stays above that line. And also to know that these decays are random. It's a random process, and you can't affect which nucleus will decay or how quickly they will decay by temperature or pressure. It's completely random, and in that way it can work as a kind of natural clock because there are no influences that can be put on it to make it decay any quicker.